Yeah, hello everyone. The VA team arrived with 3 people today, so my colleagues Michael Stanton and Jaroslav Sevcek are also here. And they also happen to work on the V8 compiler. So my name is Benedikt Meurer. I work at Google MNUG on the V8 team. I'm currently tech lead of the compiler team, which more or less includes trying to ship our new optimizing compiler, but also other tasks. My Twitter handle is @bmeurer, in case you are interested in various things about V8, Chrome, and some Node stuff, ideally. Yeah, so this talk, I'm not sure if you're aware of, but this will be a bit looking at the problem from the engine's point of view, so bear with me if I lose you somewhere. Also, feel free to interrupt me and ask questions if there's anything unclear. Yeah, so what is this ES2015? We still used to say ES6 because it was ES6 at some point, and now I need to wrap my head around this new versioning scheme. So ES6 or ES2015 is basically available for V8 since beginning of last year. So we had the sprint that ended in end of January 2016, where we could declare 99% done from V8's perspective. 99% because the tail call situation is still unclear and modules require support from the embedder as well. So our part of modules is done, the embedder part is unclear, or not fully done. For Node it's unclear as well what will happen with ES6 modules. Anyways, so JavaScript, ES2015 is the new JavaScript. No one is doing anything else anymore, hopefully. It's sexy, and TypeScript is also using the syntax, basically. So this is everywhere. But here's the catch. So ES2015 is a monster. It really is. So it took us some time. Okay, maybe monster is a bit offensive, so we could say it's huge. That is to say, what is new? So there are some things that have been there for quite some time, so like typed arrays. Typed arrays were available since roughly 2014 widely. SMJS and other technologies were already built on top of it. There are other things like generators that browsers implemented fairly early, and also promises appeared fairly early, but there are so many things that were more or less only finalized towards the end. And then all of a sudden we had this big package of everything to implement. Not only we had to, but also Mozilla and Apple had the same pain, and Microsoft. So everyone had the same amount of pain, hopefully. So there are things that are fairly easy, like classes are not too difficult because it's very syntactic sugar, and then there are things that are terrible, despite not being obvious. So like well-known symbols, I think we spend as much time on well-known symbols as on classes. Probably more, but who knows about well-known symbols in ES6? No one? Okay. Someone. Okay, there are some symbols. I will get back to that later. The well-known symbol is actually also interesting for the example that you had there, despite. So for example, there's a too-primitive symbol now that you can override, which would change that slightly. Yeah. Okay, so on our side, we are done here. We can say everything is supported in V8. There's just this one question mark on the modules, because modules require support in the browser. The loader spec is not part of the ES2015 spec, but it's part of the HTML spec. And yeah, for Node, there is no story yet. It's currently being worked out. Okay, so this update basically meant the spec went from 200 something pages to 566 pages. Yeah, that's big. Interesting fact here, it took us and the rest of the world, or not us, I wasn't part of the V8 team at that time, but it basically took the engine implementers roughly 5 years to get ES5 to good performance, or back then it was first ES3 and then ES5. ES5 wasn't that big of an update. So now we are 1 year into ES6. So you can probably expect, okay, performance is like baby level. It's not too bad because we're not starting from scratch. But okay. So how do we measure performance? Traditionally, we had a lot of benchmarks that would measure performance, but this is, in case of ES6, this is not really what you want. So what you want for ES6 is basically you want to use the new syntax and feel good about it. Feel like, okay, I'm using the new shiny syntax and not the terrible setup that I had to do with ES5. So I can just write class and not function and then function.prototype and function.prototype and so on. And you want to just say, okay, this should be roughly as fast as the ES5 version. So it saves me typing, it's easier to debug, it's nicer to read, and easier to maintain. So, which brings me to the fundamental topic of this talk, performance measurement. So how do we measure performance? As I said, what you care about is basically old versus new. So maintainability-wise or even readability-wise, new is always better, hopefully. Okay, it's arguably whether it's always, but hopefully often it's better with year 6, or with years 2015. So we found this project last year that was called HighSpeed, and the idea of HighSpeed is you basically provide a naive ES5 version and recommended ES 2015 version, and you start comparing that. So this was initially done by Kevin Decker, who wanted to use this to show the current progress of the browsers with respect to speed. And you basically define a number of micro tests, then you run them, and then you check for the same browser or for the same node version whether how much slower the new version is compared to the naive version. So the idea behind this is basically, it was done by Kevin Decker. You define the naive ES5 version, which doesn't need to be semantically equivalent to the ES6 version. It's basically what you would have in mind. So from the engine's perspective, it's of course very important that we implement the correct semantics. But for you as a developer, that the correct semantics between two versions don't matter because it's only about the observable result, and that is usually the same. So what is our goal? Short term with this new performance measurement, we want to make sure that all the new features are at least in the range of only being 2x slower than the naive ES5 version. Long term, of course, we want to be faster, or if we can't be faster, then at least be on par. So let me show you an example. For example, for us, the naive ES5 version and the naive, or the recommended ES6 version don't have much in common semantically, but from what you would expect, this is the same, right? So you would say this does the same. Sorry?
Even the left one can be optimized because it's picking each time the length, and if it stores this value, it will speed up the version.
I'm sorry, I didn't get the question.
The left one can be even optimized.
Yeah, I would argue that the right one can also be optimized. At least I've seen it being optimized in the 8, yeah. No, okay, sure. So let's say if you're using Node 6, then the right one is not being optimized, yes. Node 7 will already optimize the right one too.
Iterators are the challenge. Iterators are the challenge because behind the curtains, a lot of high stuff goes on.
Yes, I will get back to iterators and show you why it's difficult. But nevertheless, so you would agree that from the user's perspective, these two things are basically doing the same. Okay. Yeah. The framework works by defining functions and then you just feed them in. That should be clear. Okay, so before we go into some details, let me show you what we accomplished so far. So speaking of what you will get when you upgrade from Node 7 to Node 8, I'm highlighting a few of the things that we did. I think the most important ones are the first four, which is basically the iteration that I've pointed out. So iteration is almost on par now with naive ES5. And spread calls also, they went from factor of 19 slower to only 1 point something slower. So more or less the same. And obviously another interesting example is generators. Yeah, generators is the fifth item. Generators have been available in V8 for a long time and also Node, but only now became optimizable. Which is cool because everything that's going on with async functions and stuff like that is built on generators, so you want to have that fast. Good. And while we're at it, you can help us. Our problem is we are engine implementers, so we know how stuff works on a low level, but there are no really big ES6 projects out there so far that have been there for like 5 years, just because ES6 wasn't there for 5 years. So it's not clear what is important. So we can waste our time on anything, basically. We can make everything faster. Just give us enough time and we make everything fast. But obviously it would make sense if we make the things fast that you need. So we did some reach out and try to get people involved. So I sent out a performance plan, I think it was summer last year. You can still contribute ideas to that, or yeah, just shoot me a message on Twitter, that usually also works, or ping me enough until I respond. So this is one thing, we have a pretty detailed plan of what we want to do, who's currently working on this, and what is the rough design for the feature. The other thing is, we are looking for contributors to HighSpeed. So Franziska Hinkelmann, who probably all of you know, or most of you know, started the fork, and she already added like 10 or more additional items. So these are the micro benchmark things that I showed you before. So we're looking for relatively simple examples that demonstrate that the feature is currently way too slow compared to the naive ES5 version. Yeah. So that would be another thing to contribute, and obviously, yeah, we need ideas for better test suites. So Apple has one test suite that they declare their ES6 benchmark. What they ported was basically their compiler backend. So they called it air.js. Air is the backend that sits underneath JSC, which is the JavaScript engine in Safari. So basically, they test ES6 performance by running a compiler, which is probably not what the normal website does. So it might, or also not the normal Node server does. So it might be nice to get a real benchmark there. So there were some suggestions to benchmark, for example, Yarn. We tried this. Yarn is very heavy on async await. So we made improvements to async await and checked whether they reflected in Yarn. We even did it the other way around and regressed it. But they weren't really reflected, even though we had a local cached version. So we weren't doing I/O to the internet. Yeah. So if you have any ideas or anything, please talk to us. Any questions so far? Okay, then I will get to the iteration, and I'm using destructuring as an example this time. So last time I talked about this, I used for off as an example, and I think it's boring to always use the same one. So I'm using a new one, destructuring. What does it mean? Destructuring, destructuring works on objects or on arrays. I'm using the array version because that's interesting. And basically you can write variables in brackets and then they will pattern match the right hand side. So roughly what the ES5 version on the right hand side does, it takes the first element from the array. But there's a catch. A can be anything. Anything that's iterable. So, okay, normally people would use it for arrays. Let's see. So, if you run this in our development shell, so we have this D8 shell, that is basically our debug shell. It's a bit like Node, but without all the interesting stuff. It's only D8 inside then. You can run it and see the bytecode that we generate. I'm going to limit this talk to bytecode level. I think that's already interesting enough. So maybe we will follow up on it with optimized code at some point. But let's see. So we can print bytecode and see what we generate. Let's check the ES5 version first. That's pretty dense. I don't know if you know that we're changing our architecture, but this is basically what you will see starting with Node 9. For Node 8, we will still ship more or less mostly the old architecture. Node 9 will then see the new one, which means we will run through an interpreter first and then an optimizer compiler. Whereas before we had a baseline compiler that generated native code directly, and then an optimizer compiler that could support part of the language. Okay, the bytecode might look a bit interesting, but actually it's not, because it's only 2 lines that matter, which are these. And yeah, so we load 0 into the accumulator register, and then we do a keyed property load on the first parameter, A0. The 2 doesn't even matter, that's metadata. Yeah, so that's not too exciting. Actually, that's very boring. So this is JavaScript 101. Engines can optimize this for 10 years. Okay, so let's move on to something that engines haven't seen so far, the new version. Let's see the bytecode. Oh god. Okay. I couldn't even fit the bytecode. I tried various font size and spreading it around. It simply doesn't fit on the slide. There are a couple of things to note here. First, just the bytecode without metadata or anything is 285 bytes. Compared to, let me check, before I tell something stupid, compared to 9 bytes with the other version. So definitely we do something else here, or something more complex. Yeah, so why? Okay, actually Axel already cheated on this. So this is the iteration protocol. And okay, you can argue that our bytecode is probably not as optimized as it could be for this case. But you might get it. It's really complex. So what are we doing here? Let's start from the beginning. So first of all, there's a lot of cryptic numbers in there. Let's get some meaning by that. Especially these load name properties are interesting. So what are we doing there? So forget about the numbers that come later. This is for metadata. This is not interesting. But the actual names, those are encoded as constants in the bytecode, so they end up in a special table, and those are the indices for the table. So 0 is for the symbol iterate, for the iterator symbol. 1 is for next, and 2 is for done, and 3 is for variable. So what are we doing here? We pass in some object in A0, where 0 is the first parameter, and then we load the iterator symbol property from it. And then we call that. Okay, so that's basically this. And next thing, we call .next on whatever is produced first. Okay. So then we load done from the result and check if it's to Boolean conversion is false. So, oh wait. So we do this, and then we do actually load the value. So I skipped the control flow a bit. So trust me that this is really what's going on there. Okay, that wasn't even too hard. But as you can see, even the simplistic outline is already way more complex than the ES5 version. And yeah, it's not really what's going on there, because it completely ignores exception handling and it completely ignores iterator closing. This is basically the roughly 260 lines that I'm not showing here. Okay, so if you work on the VA team, then the first question that comes to mind, how can we optimize this? So what is going on here? Actually, underneath, if we start investigating what's here, then we see that we have two calls in there, and two loads and two calls that actually depend on whatever A is. And we see another thing that is not so important. We see a to Boolean. That is probably always true, because unless someone writes a custom version of an iterator that puts something else into done, it will likely be true or false. So this thing is then a no-op. Okay, but let's focus on the first part. Let's assume we always call this with an array. And in this case, to make it simple, an array with an integer. Okay, so A is an array. Let's start. What does it mean? So A symbol iterator will then probably call array prototype iterator. So added, you know what the added syntax means, by the way? This is a spec language for symbol dot iterator. I don't know, I'm used to this added syntax, but maybe you're not. Probably not, unless you're reading the JavaScript spec a lot. Okay, so what is the next then? Next is then likely calling this next method on the array iterator prototype. So this percent syntax is also spec language for internal types that are not exposed to user code. Okay, so that's something we can optimize for. Let's see. The array iterator, the array prototype iterator is basically just create iterator for values. So there are three different iterators on arrays. You can iterate the values, you can iterate the keys, and you can iterate the key value pairs. Okay. And there's another thing, the result is then, as I said, just a call to, the result is then just the result of the call to next on the array iterator prototype. So let's look it up in the spec, what it means. The spec says that create array iterator is an abstract operation that creates some kind of array iterator based on some internal prototype, and it remembers the kind and it starts at 0. Okay, that's easy. Next is already a bit more involved. And yeah, this is even using helper methods. So this is just the fundamental part. But as we see, it also deals with typed arrays, and we said we pass in an array, so maybe we can just remove that, and that makes it a bit simpler already. So if you look closely now, then what it really does underneath is something that we know how to deal with. So actually there are two things in there that we know very well. Namely, we access the length property of A, which is just as if you would write A.length. And we access the index of A, so we access the property of A, whose property name is toString of the index. Yeah, so the array property, basically, the array element at that index. Okay, that's something we can deal with. And the rest is basically a lot of boilerplate and for interesting things, which are local allocations of objects. So first of all, the iterator itself is created via object create, and And there are 4. Okay, this arrow is not really pointing to the correct thing. It should point there, but okay. Let's assume it does. And then there are 3 calls to create iter result, which is basically this tuple of result of value and done, which says, okay, it's the iteration done, and if not, here's the value, the next iterated value. And that's easy. So these things, this is stuff we can optimize, which is good. We know this because we can do ES5, so we can definitely access array elements, and we can definitely access the array length in a very fast way. So got that going for us. There are 2 new passes, or 2 passes of the new optimizing compiler that can deal with the allocations. So we allocate objects, but these objects don't escape anywhere. They are local to the function. No one accesses them. We don't store them anywhere. We don't lock them. We don't do anything. So it's not observable if we do the allocation or not. So we can completely eliminate it. And and there is the nasty details, everything else that is necessary to remove the stuff that we don't want, or that you didn't even know that existed. And if you combine all of this together, then essentially what we can provide in Node 8 now is that the new version is only roughly 1.2x slower than the old version, which I guess is usable then. So there's one gotcha. Currently, escape analysis is crashing. So we hope to have it on for Node 8, hopefully. So we have best engineers working on that. No, JavaScript.
All right.
Not me. Then you wouldn't get it, I guess. Okay, so yeah, this is what you get. This not only applies to the structuring, but also to for off, because for off uses exactly the same mechanism. It's also using the iterator. Any questions on that? Okay, so let's move on to another interesting feature, spread calls and rest parameters. Everyone is probably agreeing that arguments object is meh. Function prototype apply is also not the most beautiful thing on the planet. So someone decided, okay, we need new syntax for that. And yeah, as it turns out, so this is a very simple example, which was the initial example where we started with for spread calls. So instead of using function prototype apply as in the ES5 version, you can just use the ... operator, which automatically spreads whatever you pass to it, and calls, in this case, calls max with 3 parameters. Yeah, this is fairly easy, except that there's a gotcha, because this is also defined in terms of iteration. So if you remember what I just showed you, then all of this machinery has to be thrown at that as well. Which was one reason why this was initially 19 times slower. Because function prototype apply is very simple. Function prototype apply just loads the length and then iterates through the elements and done. So this is the fast thing that I showed you. The fast access, and spread goes through the iteration mechanism, so it has to do all this overhead that is also necessary for the structuring. Okay, but nevertheless, we found a way to make this simple case at least very fast. So it went from 19x slower to 1.x slower, 1.5x slower in Node 8. And that is probably okay. So we know how to go from here. There's still some things we can do. So, for example, inlining will not work through rest parameters currently, and through spread calls currently, but that will work in Node 9 then. Whereas, for example, for Node 7 and Node 8, we would, in some cases, inline through apply, which already works. But we get there, so step by step. Okay, but this is also a very simple example because it's really trivial. Let's make it a bit more exciting. We have a function that takes rest parameters. So this is my version of max, which caps at 0 basically. And it uses a spread call that also passes one normal parameter. And yeah, want to see the bytecode? Yeah, I think so. This is bytecode. And it's like, whoa. That looks like a lot. So let me run you through this example. What is this doing? So first of all, we need to create args responds to an array, rest parameters. It's just it collects everything that's passed beyond this, beyond the last formal parameter. Just collects everything into an array. This is what the first bytecode does. It produces this array. Then we go on and we have to load the global math. Okay, that's easy. Then we load from this global, we load the max property. That's also easy. Okay, then something weird happens and we create an array that contains 0. Okay, let's assume that makes sense. Okay, then we go on and then we have to do this usual iteration thing on the arguments. So we spread them. This is basically a for-off internally. So it implements the iteration protocol. Then we combine those two arrays to produce another array. Okay, and in the end we use the underlying apply mechanism and call mathmax with args. Actually, the undefined is also incorrect because it's the receiver would be the receiver is undefined. That's actually incorrect. Okay, so that's a lot of work. And if we take another look at that, what it means is basically we allocate 4 temporary arrays here that the user doesn't even see. The only array that you sort of see is the ... args, but that's all. All of the other arrays are completely under the hood. So we waste a lot of time and we probably trigger a lot of GCs then. Okay, so what it means, we really need to work on our bytecode. And a new bytecode that implements the whole spreading logic will probably solve it. So let's see. What would this thing do? So it would basically implement the spread call and in a way that it takes the target. The target is the function being called. And in addition, it takes the receiver, which is math. Actually I was wrong. Math is the receiver. And the explicit parameters and the last parameter that is to be spreaded. We will only currently focus our work on optimizing this case where the spread is the last parameter. We don't really, so actually it's not, the spec doesn't limit it to that, but we don't really see a good use case for spreading somewhere in the middle. That's also not what we see in the wild, because then people usually use function prototype apply and then push some arguments to the end. If there's a good use case for doing something else, then we are interested to hear, and we will likely also optimize the other case. Given that this is not really in V8 yet, but it will soon land soon, and then the whole bytecode reduces to this. So this is fairly close to the optimum. The only thing that is there to optimize is basically in the optimizing compiler eliminate the rest parameter allocation completely, which we might do as well, or we will likely do. Good. Okay, so as I said, this is work in progress. You won't see this in Node 8 and hopefully Node 9, or pretty likely Node 9. So I guess this was pretty low level already. These were success stories, so it's easy to tell them. But actually, ES6 was not always a success for us, so we also had some accidents along the way. And Node, not only Chrome users were unhappy sometimes, but Node users also had to experience this. For example, one day, not so distant future, this popped up on my machine. And there's only one interesting thing in here. Fuck. Okay. Damn it. This was not good. So that was me. Okay. But fortunately, someone already spent some time looking into this. In this case, it was Benedikt from Node, who was pretty capable. And he figured out that some Node commit that happened did this. Okay. So I was like, yeah, okay, Node folks broke something. Okay, let's dig a bit deeper. Aha, damn it. I have some idea what this could be. Okay, let's dig deeper. That's a well-known symbol, damn it. I implemented this instance of optimization in the end. Okay, so let's look what they do. Oh, damn it, they use this symbol. Okay. If you use this symbol, or if you use it back then, you basically disable any kind of optimization that we do for instance of. Okay, why? So the spec ES6 added this symbol.hasInstance, which I use the added syntax. And that makes instance of monkey patchable. So you can, previously it wasn't monkey patchable, it would always walk the prototype chain of the right hand side and see if you're, it was always check if if the prototype of the left hand side is the prototype property of the right hand side. That was optimized since, I don't know, since probably the first version of V8. Okay, so we wanted to retain this nice fast path that we have in there. So we added, so we thought, okay, no one would install simple as instance anyway. Good assumption. As it turned out, that was not the case. So, okay. So we added the global guard that basically protects our optimization. As long as no one monkey patches instance of, we're good. Okay. On the web, that was fine. Who would have thought that someone added this to Node Core? Yeah, whatever. Okay. So this is our optimization, or this is the guard for optimization. If you install symbol has instance as a property, or use this as a property name anywhere, the global optimization, the optimization is disabled globally for the whole VM. And yeah, further instance of always take the slow path, which can be up to 100x slower. This is what the spec says now about instance of. It's a bit boring spec text, but it's also not too difficult to figure out. So this is basically what ES5 did. Everything else was not in ES5, so this is what is fast, or what we knew how to make this fast. And yeah, this is pretty slow, so that means you have to look up the has instance symbol on the constructor first, get method, does some additional checks, and you have to call it in the worst case, convert the result to a boolean, and yeah, that's not super fast. Okay, so we had to do something. We couldn't leave it this way. So any Node application was affected because it was a Node core. So any Node application was at 100x slowdown, for instance, of. People were noticing this already and we're not particularly happy with us. Okay, so we need to avoid the global protector, and this is not going anywhere for this. And instead we need a local fast path for O instance of foo, where foo is some globally known, some known constructor. So something where the optimizing compiler already knows that okay, foo refers to this function or this class, and I know exactly what it is. And as it turns out, it wasn't even that hard to fix it. So once we know what I had to look into, it was fairly easy. Because I could just simulate this lookup during compile time. and then bake in the result into the optimized and compiled, into the optimized code that was generated. And yeah, okay, so this was my patch. Crankshaft, no one wants to read crankshaft code, no, whatever. Okay, if you look closely, it doesn't really matter, so it's, forget about all the rest. So you see, this is what we did before. We used our global protector to enable or disable the optimization. And okay, we can be smarter. We just check whether the right-hand side has instance and whether it's the default has instance. And if so, then we use the optimization. So we don't even need a global protector there. Except for the baseline case, there we still need it, but baseline is not so important, for instance, because if you run the same function 10 times, then you probably already optimize your function anyways. So then you get the optimized code. Okay, so some image repair to happen. I had to hurry to get this into V8. So the patch was fairly simple. It was actually necessary, otherwise backmerging to Node 7 wouldn't have been possible. Franziska luckily picked it up early and pushed it into Node, and everyone was happy. So yeah, stuff like this happens, especially when you assume you want to retain your fast path that you had before. And so actually we thought a lot about instance of it. A couple of people worked on this, for example, Michael Lords worked on this. And we had a couple of ideas, but in the end this seemed like, or this was the only thing that really preserved the performance for all the benchmarks where we were measuring instance of. Yeah, but it broke Node completely. So it's trade-off space. It's a big trade-off space. Okay, questions so far? Okay, so let's leave.
Yeah, I'd just like to make an observation. I mean, this strategy that we use, that we call a global protector.
Yeah.
To me, it seems like it comes from an underlying thought that, oh, nobody's going to use this thing.
Yes.
Like no one's going to be silly enough to use that. So if somebody does use it, in the whole page or whatever it is, then okay, you're punished. It goes slow for you. This is I think what makes your earlier slide very relevant. The asking for help from the community, from people who are using ES6, writing real ES6 applications. Often we need to be spanked in a way, to be told, hey, no, we are using these features, destructuring, whatever it is, so that we are not tempted to create global protectors.
Well, some global protectors make a lot of sense. So, for example, we have a global protector that protects the array prototype chain, and which means if someone ever installs elements on the array prototype or the object prototype, or changes the links in the prototype chain from the array prototype to the object prototype to null, then this protector gets invalidated. And so far we haven't seen any example where this was the case. So this is a good protector. And this protector allows us that if we see a hole in an array, and the array has the array prototype chain, as the array prototype, then we can just replace the hole with undefined, which is a very good optimization. We don't need to walk up the prototype chain to check. This is also what other VMs do, by the way. So this is not a V8 specific optimization. And this global protector makes a lot of sense, because hopefully no one, or we haven't found anyone violating this, especially Node Core doesn't violate it, which is important. So yeah, it's trade-off. But yeah, as Michael pointed out, so help is always, you can help. You don't need to be, so obviously V8 as a project is a bit scary and also has a really high entry barrier to entry. But you can help in other ways. So you can contribute to V8 by contributing ideas or contributing feedback. And yeah, we are looking for that. Okay, so yeah, let's forget about years 2015. That's 2 years old now anyways. Who cares? ES2017 is the new shiny language, whatever. Okay, what's new? We could probably ask Axel, but I think we all know that there's one feature that everyone wants, and this is async await. Does anyone know of any other ES2017 features?
Object of entries, for example?
Yes. Okay. Object entries, object keys, object values, string left pad, string right pad. Who uses that anyway? Okay, so async await. We're not stuck with ES 2015. We are already working on performance of ES 2017, and we're running into the same problem. As I said earlier, we try to use Yarn as a macro benchmark to measure async await performance. But yeah, so Yarn doesn't show any improvements if you improve the performance, so that's not a good benchmark. So we came up with our own very simple metrics. As you can see, there's basically one interesting thing here, which is the light blue line. This is a baseline implementation on promises, very naive. And then there is our native implementation and the Babel transpiled version of this. Without going into detail, this is the async await version, and this is the same thing with promises. It's really stupid, but we can exercise the VM a bit. So, yeah. We are still looking for input for a more useful macro benchmark, even for async await, that reflects some real-world use case without bringing in I/O. So this is the problem. So obviously we could measure fetch or other things, but as soon as you drag in the browser or Node tasks, or like I don't know, whatever uses promises in Node Core, you're no longer measuring async await itself, as we figured out with Yarn, but you measure something else. And your performance improvements don't show up. So what we're looking for here, some meaningful async await performance test. It's unclear what is necessary, what should be fast. I don't know how many people are using this natively. So if you use Node, if you use recent Node, use it natively. If you have to deploy a Node, I think Node 7 can use it, yeah, but you need to pass in the -- harmony async await flag. Node 8 will definitely have a native async await, so please don't transpile it, please use it and tell us what you think. As you see, definitely the transpiled version won't bring you anything because Babel is constantly lower. This is the dark blue graph, so we definitely beat Babel already. From the get-go already, so yeah, please use it, please provide feedback on whatever you need. Yeah, and that was it for me, basically. Thank you for your time, and I hope you could use some of this. It wasn't too deeply VM talk. And yeah, if you have questions or feedback, please come to us. We're here.